Yeah, hello everyone. My name is Michel. I'm a researcher at the Helmut Schmidt University here in Hamburg. And I'm part of the Interfacer project, a little bit like keeping in mind also the physical layers or the production layer in all the software part and digital parts. So here I'm going to present you a concept of a microfactory. So I'm not going to go too much into the physical, but a little bit into the interface between our digital sphere and the production sphere. I want to start with the topic of planetary boundaries. So we had a workshop at our institute, and when we talk about circular economy and how we want to shift our economy to a regenerative system, there is a framework developed. It's called planetary boundaries. So what's about? It's about environmental limits. So it's like derived parameters, model-based parameters, which define our sphere where we can live in, so where we can like really as a humanity live in a safety space. So here's like control variables. You see difference like biodiversity. Maybe you know that biodiversity is a parameter which is really in a bad condition. We have like parameters, also climate change. What we know about today is the climate strike. So this is maybe also one point we can keep it also again here in this room. And I think climate change is also one thing we know production is very heavily has impact on the climate parameters. And this is also the frame where I want to start with. So keeping in mind like control variables where we have to track and keep in mind when we want to shift our production. So starting a little bit also from the science and from the industry, what we know about, like what methods we have here, like circular economy, I think we know it's like a regenerative system, like we want efficiency, so use our materials, use our resources in an efficient way, so don't waste it. And we want closing the loop. And that's also in the manufacturing sphere, so closing the loop, closing our product loop, multiple life cycle of products, so not just using it and then throwing it away, but reusing it. Therefore, we need to shift to our manufacturing. We know like manufacturing systems, when they're designed for a predefined output. And they need to run this output for a couple of years. And that's why we are like stuck, we need this output. And therefore, there's like a concept, it's like changeable manufacturing. So be flexible, be ad hoc. When we see like there are events like we've never thought of and they're coming, so we need to change them. So there are like three concepts. It's like changeovability. So also like with the idea that we want a variety of products, that we want to keep in mind our creativity, we want to keep in mind like different products and so on. So the changeovability, like producing different variants. So in a manufacturing system needs to change. We need to have flexibility, so we want to run different products. So then we need to keep it flexible by rerouting our change or reprogramming. And the last is like really the reconfigurability. So when some product is coming into the factory, we need maybe new modules, new processes within this factory. So this needs to be reconfigurable. All these steps need time, knowledge, information. So this is why it's hard just to make it like this. Yeah. Okay, but this is like a concept we want to show. We want to try to keep in our concept. Now the factory. What is a factory? I mean, that's like a classic description of it. It's like the reference is from our Association of German Engineers. I mean, it's a space of value creation, right? So in factories, value creation is taking place. It's a division of labor for produced goods. And we're using production factors. Production factors are mainly like the material, like the energy, like the information, and also the people we're working in. And then we already have also concepts of microfactory, which are coming. So microfactories, also in the science, is like it's a highly modular, flexible, and automated production facility with a low spatial and ecological footprint. And also with a minimal invasive integration into given infrastructure or also new infrastructure. So within an urban space, where space is really like, we don't have so much space, in a region we have it maybe a little bit more, but we want to integrate it minimally invasive. Yeah. And it's also demand-driven, so it's stimulating demand-driven innovation which is taking place in the space. So these are like a little bit of the physical layer. Now we're coming into the digital layer, and therefore maybe also some buzzwords, you know, it's like Industry 4.0. And industry also have all these data-based methods and models for increasing efficiency. The target goals are sometimes a little bit different what we are thinking, so the objectives. But the methods are there. So one concept I want to point out here, it's called the cyber-physical production system. It's erased from the need because of lots of networked and integrated embedded systems. So embedded system means really near to a physical process and controlling a physical process. And keeping this, CPS stands for cyber-physical systems. When we have a physical system for a production, then we're talking about a cyber-physical production system. And this like mainly data processing, data storage, and a communication interface. So giving data also further or taking new data within. Industry 4.0 has also a reference model, so we have different layers here. I don't want to go in detail for every layer, but just to show you what like in industry is going on. Like also from one layer going to the asset, like really to our, I would call it common, not the asset, till the business layer, what we have here, and also keeping in mind the life cycle. I mean, unfortunately, it's not yet circular, the life cycle, but we want to adapt this life cycle into a circular way. But here you see also different layers for the integration within production systems. And when we have like our digital platforms, we can keep in mind these layers which are already there. But unfortunately, most of these results here are proprietary. So would be nice if some industry leaders are here, open source your results, that we don't need to reinvent it again. Okay, then I want also this fear of open labs and open source hardware, just briefly also to bring here again, like open labs, what we have as a concept, like makerspaces, open lab, fab labs, want all to keep this together, but just pointing out open labs is like spaces, self-organized and collaboration-oriented projects, okay, so bottom-up projects. And increase participation, like really like local community, we take the local community and are co-creating methods. Open source hardware on the other side is like open information and knowledge common, so everyone can use it. It's getting more and more standardized, so when we have here the field of Open Toolchain Foundation, we also have in the project like standardized repository structures, etc. And we have to write with these open source hardware to redesign it, to reconfigure it, and to repair it. So now to the concept, so to compile everything together. It's like the first thing, it's the scope. So here we have also my colleagues, so also nothing is just for me, so we have a team here with my colleagues. Call it like the hybrid concept. So we want to create a complementary entity. So between the maker, the Open Labs infrastructure, and industrial production. We want like small, medium batches. So we know like makerspaces are lacking of batch volume, okay? So the production layer in makerspace is really small. Also the complexity which we have in products, it's not so high. I mean, now here in the Microfactory you see a coffee grinder, which is like nearly completely produced here. So the complexity is quite a little bit higher, but still lacking here on this side. And we want also to have like a demand-driven and service-oriented. So really the question is then what is the demand, right? So this we have like to develop together. And we want to have a professional operation. That means a little bit to distinguish between open labs, where like everyone is coming around, trying, erroring, which is nice, but in a factory, we really want to produce stuffs. So here's a little bit the pillars I want to introduce for the concept. So planetary boundaries, keep in mind that's our boundary, so we can't play around it. We have open source hardware and software. That means like preferably, not exclusively, so not just we are producing open source hardware, but preferably because we can really redesign it and reconfigure it. Also the use within the factory is based on open source software tools and hardware, means open source machinery. So with this we really have like sovereignty over our equipment. Then the hardware itself the factory itself is like open source hardware. So we want to publish the design of our factory so everyone can replicate it. Then we have also one field for open data I want here to bring in. So especially data for environmentally influences. So like energy data and material data. And this was also a question from the EU at the beginning, who has access to this data? It's like entities into the value chain. I think when we have like data from environmental data, we are all impacted. We are all influenced by. So it means like the data should be really open to all of us. It's like one thing we have to discuss, right? Like, because it's sensitive data. Thank you. Yeah, then the third pillar is like circular manufacturing, right? So we have a changeable microfactory, the concepts which are there. It's like database, demand-driven, service-oriented, and also use these concepts of cyber-physical systems and also to have peer-to-peer exchange, which really means like peer-to-peer, the whole factory as a peer entity, but also the machines and the stations within the factory as a peer entity. How to organize it, also another question, but in the concept, you can see it. And then open labs as one really, as an important pillar where methods are created and developed in a co-design level. And we want to use these methods also to say, hey, look how we can produce maybe, and see how we can transfer these methods also within the microfactory. So these are the four different pillars, and then it's like one we left out a little bit is the design part, okay? So this is really like the factories for the production, the design is taken care like in a distributed way, which we already know, like open source hardware, distributed design, etc. So that's not included within the microfactory concept. Here's a little architecture, you can also see it at the poster. I also don't want to get into it overall. It's just like to have a little bit a high-level architecture what we have. I mean, we have also the factors in the beginning, like energy, material, and data. And here I want to show it's like we have different entities. So the factory as itself seen as a cyber-physical entity, and within it also cyber-physical entities. It's called like stations. And the most important one is like recycling stations and disassembly stations. So to have capability to get the products which are used to reuse them within the process chains. Then we have like different machine stations, like what capabilities and how they're like equipped, we will see. Like, do we need universal machines? Do we have like here already, we have machines where we can switch tools, right? So we can already produce in different ways, yeah. And also like the distributed station. And all with them are capable with cyber-physical functions. So that means like we have a communication interface, so they're all data-based. We have an automation interface. So automation is one thing I want to keep here in, because I think with automation we can really like, yeah, a little bit lay down ourselves and let the machines do the work, but we can also discuss this. And also to have like peer-to-peer communication in a network in a top layer. So also the microfactory for itself has like an overall data management layer. So for contributing all the order management, factory planning, and so on. But also within the whole city we have like one layer. Maybe it can be the FCOS as one entity. Maybe another application which can come on. Yeah. And for sure, like also the humans, the people which are working on, and just like one first step, like to say we have operators, we have maintainers, and we have service technicians who are implementing new function within the factory. Okay, so this is one example, what we see here, like we have the machine, and then like few functions around it on the physical layer. Post and pre-processing, like really to be flexible, to see tolerances, to compensate these tolerances, energy material tracking, quality checking, so really that we have a good quality, and then also the field of automated material transfer. So maybe you have like the automated guided vehicle is one concept, so really that it's like flexibly within the factory to transfer material through other entities. And then, like I said, automation layer and the communication layer on top of it. Yes, so these are like the points. Still got time? Yeah, so quick conclusion about the concept. It's like using existing industrial models and methods for database circular manufacturing systems. We can see it, we can look at them and try to use them. Use open source software and hardware equipment to have a sovereign design, configuration, and operation possibility here, really to be sovereign on it. Then open labs are spaces of co-design for new methods, for circular design and production, and a common-based peer production, also around the organization of a factory. And the last, and for me really the most important one, provide the open data and a community monitoring for transparent tracking of the planetary boundaries control variable. And also some discussion point here we can really also discuss later on. It's like how much data and automation is needed. Because we also know from the labs, it's like we like to work with our hands. We like to be also as a human in the place of production. So how much automation is good or bad? So this is always the question when we use automation. Is it too abstract when all is data-based? Like we really need to stick also on the physical world, also on the social world. So what's the human within this factory? And for sure, when we talk about data, it's the security and the privacy layer too. Then quality standards, when we have like methods coming out of open spaces, how can we transfer them to a factory space? So what standards do we need here? And also the thing, again, with data, it's like decision making and action. It's all based on model-based matrices, all data-based. When we have like complex systems and not determinate systems, it's really hard to model a system. And then can we really always decide on these data-based results, or if someone said, oh, sorry, I just miscalculated myself, and we took action because of this. So also the question here. Yes, so this like quickly the concept of a microfactory. Here's here also the poster, and yeah, maybe I have quick time for a little, no, okay, then afterwards. Thank you very much.